Hello. Today's success criteria is going to be that I can rewrite exponential equations as logarithmic equations, and actually we'll do vice versa as well. We'll start with a log, and we will try to end with an exponential equation. Okay, so let me show you what this looks like. This will be brand new for most of you. Um, here's the big idea at the top. I made two little boxes. I have the base to the x power, all right, is going to equal a value, some sort of number. And next to it, I try to use the same variables so you can see kind of how things are placed. The base of my power is going to be the same thing as the base of my log. And the way that we write that is a little subscript, kind of like in your chemistry class. It's going to be a little number below the log. Now, the answer that we got for the original exponential equation is going to be in parentheses right next to it. And the exponent is going to be what that expression is equal to. Okay, so let me show you an example of how to rewrite an exponential equation into a log equation. All right, so example 1. All right, I have 2 to the 5th is equal to 32. And that's a true statement. You can check that on your calculator. If you were to take 2 to the 5th power, that's 32. But I want to write that using logs. So what I'm going to do is I'm going to say, let me get a better pen here. Okay, so let's say I have the log. So this is how we're going to start. Now the base of my power is going to be the base of my log. All right, so it's a little subscript there of what it was equal to, which is 32, and that will always be equal to the exponent. And that's actually what logs do. Logs find exponents. That's their purpose. Okay, so they're the inverse of an exponential equation. All right, and that's all you have to do. So today's lesson is just converting from one form to the other. All right, so we'll do a couple examples. So same thing, example 2, I'm going to say log, the base of my power is 81, of a value 9 is going to be equal to the exponent of 1/2. Okay. Example 3. Okay, in this case, I just use variables just so you can see the placeholders. This might be the most valuable example, so you can see how everything moves. So I have the log, the base is the x, it's equal to the z, and my log should always be equal to the exponent of the exponential equation. So that would be my log equation, okay? So the other part of this, the second half of this is, can you go backwards, right? So can we take a exponential equation and write it as a log? And I have a few examples here. Can you take a log and convert it back to an exponent, okay? So the way that I do this is the base of my log is 4. I know the exponent has to be 3, and that's going to be equal to 64. Okay, so always remember, the base of my log is still the base of my exponent, or my power here. What the log is equal to is always the exponent. Okay, so this number is always my exponent. And then whatever was in the parentheses, that's going to be what that power is equal to. So if we do the same thing, I say 6 is my base. I know the exponent has to be 3, and that's going to be equal to 216. All right, and you can actually check that on the calculator. That is a true statement. 6 to the 3rd power is 216. All right, so I have one here. Same idea, but with variables. So the base of, I put a B. It should be an R. My bad. Let's get rid of that. So I have the base of my log is R. The exponent is T, right? And that will always be equal to what's in the parentheses, which is S, right? So again, the purpose of this, I can say it over and over, is to be able to rewrite from one form to the other, kind of understanding this relationship between exponential functions and log functions, okay? We'll get into more details later on what these log functions can do and how we can use them, all right? I have a couple tricky ones here. There's just two. Some things I need you to be aware of. All right. So it says convert the following log equation into an exponential equation. Now, if you have a log with no base down here, okay, So this is what I need you to know. Make a little note in your notebook. If I have a log with no base, then it's assumed to be base 10, always 10. So if there's no number written there as a little subscript, then it's always base 10. So I'm going to say, I know the base is 10, the exponent is 3, and that's equal to 1,000. All right, and I'll have a problem like this on the assignment. So make sure that you watch this video, make sure that you know. Anytime that you don't have a log or a base for that log, that base is 10. All right, now I have just another one here so you can see. So there's no base written here, so the same thing, it's always a 10 to the 0 equals my answer. I guess I don't really need parentheses. Let's get rid of that. Is equal to 1. Okay, so 10 to the 0 power is 1. That's true. You can check that. We're just rewriting from one form to the other. Now, one problem that I don't have written here that I want you to be aware of that's going to come into play. You will also see there's a very special log that looks like this. Okay, it's ln with parentheses. And what this means is it means it's a natural log. That's the name of it. Okay, so it's a natural log. And what this means is it's log with this letter E. Okay, now E in the world of mathematics has a value. It's like 2.71, something like that. It's on your calculator. It's kind of like the number of pi. All right. So if you were to ever see, let's say, the natural log of 5 is equal to x, you can actually do, the base of this would be E. So we can say E to the x is equal to 5. Okay? And this would be writing it from one form to the other. All right? So if you ever see natural log, it's always base E. If you ever see a log by itself, it's always base 10. These ones are the tricky ones. All right? But everything else, every other log that you see should have a little subscript, and that tells you what the base is. Okay? If you have any questions, please email me. Otherwise, please follow up by doing the assignment. Very short, and good luck.